welcome Larry Ellison.
Thank you. Thank you very much. Thank you. Thank you. Thank you. And I'd like to take a moment to thank Toyoki-san and Yamamoto-san from Fujitsu. You know, Oracle and Fujitsu are working on the next generation of Spark microprocessor. And I'm going to make a promise to you. By this time next year, that Spark microprocessor will run the Oracle database faster than any other processor on the planet. And the way we're going to do it, is by moving a lot of software functions into silicon. So I'd like to thank our partner Fujitsu. Fujitsu's silicon engineering team is working with our silicon engineering team to develop a new generation of microprocessors that deliver extreme performance by merging or moving software into silicon. But that is not what I'm here to talk about today. I'm here to talk about cloud computing. You know, it's interesting. Back in 1998, or I should say in the late 90s, the first modern cloud companies were born. The first modern cloud company formed was NetSuite, formed in 1998, and then Salesforce.com was formed 6 months later in 1999. That was a long time ago. But that was really the beginning of it all, the beginning of this new era or alternative era to traditional on-premise computing. An alternative to buying hardware, buying software, and running it on-premise. You can now buy business applications, any kind of applications really, and purchase them as a network service and pay a monthly fee. You can buy platform services. You know, all of these applications, if you're going to buy an application from a SaaS company, you might want to extend that application. You might want to connect that application to another application. You might want to share data, move data back and forth between applications. You know, you buy your first SaaS application, you have a lot of applications on premise. You got to connect those applications up. You got to share data. For that, you need a platform. So when you have a SaaS application in the cloud, you want to connect it to other applications. You need database services and programming services and all of those things. And those are now known as it's called platform as a service. So if you have applications as a service, that really means you need an underlying supporting platform to connect up your SaaS applications with each other and to on-premise applications. So SaaS kind of gave rise to PaaS. Once we had SaaS applications, we needed a platform underneath them. And all the SaaS companies provide some kind of platform. But the SaaS companies primarily are application companies. But platforms came in after SaaS. Finally, and again, this is back in the late 90s, 98, 99. In 2006, Amazon.com announced the Elastic Compute Cloud. Very different than the early SaaS companies. This wasn't a sales application or an accounting application you could buy as a service. This was raw compute power you could buy. You bought a virtual machine, an operating system, hardware, server, and storage as a service. And the Amazon Compute Cloud, again, came in about 8 years after the early SaaS companies. Together, all of these ideas, an application as a service, a platform as a service, infrastructure as a service, has grown more and more popular. And Amazon's term, the Elastic Compute Cloud, became very popular, and the term cloud computing was adopted by the early SaaS companies. And now all of it together is known as cloud computing, an alternative to on-premise computing. The alternative being buy your applications as a service, buy your database and middleware as a service, buy your storage and servers also as a service. Next slide. Oh, I just press the button. I don't have to say that anymore. Okay. Now I have something for each hand. Okay. All right, there's a lot that's attractive about cloud computing. One thing is the complexity is hidden from the consumer of these services. The software, the servers, the storage, the network, all of that stuff is managed by the service provider, the cloud company, not the consumer of the service. You don't have to buy storage and servers. You don't have to buy, do software upgrades or hardware upgrades. All of that stuff is managed for you by the service provider. Customers have to have a simple device, either a browser on your personal computer, a smartphone, a tablet, and you can access all of these services across the network. Another thing people find very attractive about cloud computing is the cost of capital is borne by the service provider, not by the consumer of the service. So the cloud company buys the hardware. The cloud company buys the software. The cloud company maintains all of this stuff. And the consumer simply purchases capacity as needed, on an as-needed basis. You need more capacity, you buy more capacity. You need less capacity this month than last month, you pay less this month than last month. You pay for the capacity used. There's no upfront capital outlay. What a good idea. Except it's really a very, very old idea. The architecture, the fundamental architecture of cloud computing is really a utility model that's been with us for, I don't know, 100 years or more. The architecture of cloud computing looks exactly like the architecture of an electric utility. The electric power utility is responsible for generating electricity. They can do this through coal-fired plants, natural gas, wind, solar, nuclear. All this is enormously complex, capital-intensive stuff. But all of that stuff is managed by the electric utility and provided to the consumer as a service. The utility manages, pays for the generation of power. The utility distributes the power over the power grid. All of that stuff is managed by the service provider. The consumer of electricity simply plugs in to get it. Very simple user interface. All the capital costs are borne by the utility. The consumer simply pays for capacity as they use it. If they use more capacity this month, they pay more. If they use less capacity, they pay less. 1 second, please. That's 3 things to hold on to. A little harder. Okay. So, cloud computing, begun in the late 90s, has become more and more popular to the point where last year, Oracle made an announcement. Now, we didn't decide to get into cloud computing. Let me try that one more time. Cloud computing last year. We decided to get into cloud computing back in 2004 when we started our Fusion Applications project. And I'll talk more about that on Tuesday. But it took a long time for us to build a complete suite of cloud applications and the all-important underlying platform for those applications. And that was the issue. We had to build the platform first, a modern platform first. And we call that platform Fusion Middleware. We had to build the platform first before we really could build the CRM applications that ran in the cloud, HCM applications that ran in the cloud, ERP applications that ran in the cloud. We had to build the foundation before the building. We had to build the platform first, and we did. Now, Oracle has a huge advantage in platform services in the cloud because Oracle happens to be the #1 platform company in the world. We have the most popular database in the world. We have the most popular programming language in the world. We have the most popular middleware in the world. And that's the platform. And we enhanced those things. We enhanced the database. We enhanced the middleware. We made those enhancements to support our new cloud computing offering, our Fusion applications. And again, we started working on this way back in 2004. And then in 2011, we got to the point where we could announce this and start delivering cloud services, both at the platform level, database services, middleware services, and at the application level. HCM services, CRM services, ERP services. But it's interesting. In our first year of delivering cloud services, we made a discovery that it wasn't enough simply to be an application provider and a platform provider. But the people that wanted to take cloud computing seriously and look at cloud computing as an alternative to traditional on-premise computing needed a combination of SaaS and PaaS and also infrastructure as a service. So today, the first of 4 major announcements I'm going to make today. Today, we are announcing that the Oracle Cloud is offering infrastructure as a service as part of our cloud offering. Because our customers who are running our SaaS applications and our customers who are running our platform services have said they need, in addition to those 2 things, they need to run certain kinds of custom applications and move some of their existing applications onto the cloud as well. And the only way we can do that, the only way we can accommodate that is to offer infrastructure as a service in addition to SaaS and PaaS. Now, the infrastructure that we're offering isn't conventional infrastructure, if you will. It's not plain old commodity infrastructure. What we're offering is our OS, our VM, compute services, and storage services on the fastest, most reliable, most secure machines in the world, our engineered systems. Exadata, Exalogic, superclusters, Exalytics, all networked together with a modern InfiniBand network. As we move from, we're actually not moving from being a traditional supplier of hardware and software. We're adding a new line of business, cloud computing, to our existing traditional line of business of selling software and selling hardware. We're also going to sell software as a service now and hardware as a service, infrastructure as a service. And we're going to sell it on the fastest computers in the world, Oracle's engineered systems. Now, it makes a lot of sense for Oracle to be in all 3 tiers of cloud services because Oracle has participated in those 3 tiers for a very long time. We are the #2 applications vendor in the world behind SAP. We are the #1 platform supplier behind nobody. And ever since we bought Sun, we are a major supplier of operating systems, servers, and storage. So we make investments at all 3 layers of the cloud. Our customers, to fully embrace cloud computing, need to have all 3 layers of service and high quality at all 3 layers of service. When we decided to offer infrastructure as a service, we talked to a lot of customers. And while a number of customers are excited about using Oracle's infrastructure as a service in our data center. Some of them, banks for example, banks outside the United States, some of them felt more comfortable if their data and those servers were located behind their own firewall. Now they still wanted to have it be cloud, be true cloud. And true cloud means we have to own the infrastructure. We have to manage the infrastructure. We have to upgrade the infrastructure. But because of, say, banking regulations or something else, they felt that that server needed to be on their floor behind their firewall. So we decided to have an option on the Oracle infrastructure as a service. We could put that service in our data center and run it for you, or we can put that service in your data center, we'll still run it. It's identical. It's the identical infrastructure on our floor or your floor, you decide. We give you that option. So today we're announcing the Oracle Private Cloud, an extension to the Oracle Cloud behind your firewall. Again, it's exactly the same as if you buy the infrastructure in our data center. We own it, we manage it, we upgrade it, you pay a monthly fee and you only pay for what you use. And we actually install, when we make an installation, we work with you trying to estimate the amount of usage, and we install excess capacity beyond that estimate. Announcement number 2, the Oracle Private Cloud. Now the Oracle Private Cloud, like Oracle Infrastructure as a Service on the Oracle Cloud, runs, as you would expect, Fusion applications. So if you want to run Fusion applications, you can run it on computers you buy and install in your data center. You can run it on a private cloud, or you can run it in the Oracle public cloud. You'd expect Fusion SaaS applications to run on the private cloud. What might surprise you is eBusiness Suite, PeopleSoft, Siebel, custom applications. They run on the Oracle private cloud as well, because the Oracle database runs on the Oracle private cloud. Oracle middleware runs on the Oracle private cloud. You can develop new applications on the Oracle private cloud. So you have a lot of options and a lot of flexibility with the Oracle private cloud infrastructure as a service. It allows you to do pretty much everything on hardware and software that is managed by us. Now, the Oracle Private Cloud quite literally is an extension of the Oracle Cloud. You can't tell the difference. The software is identical in both places. So you can build an application in the Oracle Cloud and move it without change to the private cloud. You could do all of your development on the Oracle Cloud and all of your testing on the Oracle Cloud and run production on the private cloud. Move the application over, move the data over, and you're ready to go. There is no difference. It's identical hardware and software. You can use the Oracle Private Cloud as a standby database, or the Oracle Public Cloud is a standby database for a production application in the private cloud. You can use the Oracle Cloud as disaster recovery for the private cloud. Again, they are interchangeable. You need excess capacity, you used up everything that's in your private cloud, you can now start using the Oracle Cloud. It's the same infrastructure, the same operating system, the same virtual machine, the same hardware and storage services, the same platform services, available both places. So, with today's announcement, Oracle's committed to delivering services at all 3 levels of the cloud: SaaS, PaaS, and infrastructure. Just because it runs in the cloud doesn't mean we forget everything we've learned in the last 20 years of working with computers. Industry standards are still important. So all of our applications are written in a standard language. I mean, all of our Fusion applications, our SaaS applications are written in a standard language, Java. Our database implements industry standard SQL. Our middleware is all based on Java. All of it is industry standard. Security is very important. Reliability is very important. Scalability is very important. Just because it's now in the cloud doesn't mean those things are less important than when you were running that stuff in your own data center. And we think we're ideally positioned to take our experience in platforms, services, in database and middleware, and move that to the cloud and deliver the same set of industry standard services, the same high quality, highly reliable, highly secure, highly scalable hardware and software that we deliver on premise. Announcement number 3. What we offer in the cloud is about to get better, a lot better, with the new version of our database. We've taken more than 4 years to develop this new version of our database, Oracle 12c. You might guess the C is for cloud. It is the first multi-tenant database in the world. Spontaneous applause, that's great, thank you. Database was always one of our strong suits. And I'd like to thank Andy Mendelson and his team for working on this for, probably closer to 5 years than to 4 years to get this done. As I said, when we made this decision back in 2004 and moved to the cloud, that we needed basically a new foundation to support modern cloud applications. We did a lot of work to improve our middleware so it would support our SaaS applications. We've also done a lot of work on our database so it will support modern SaaS applications. Now, traditionally, SaaS companies have implemented multi-tenancy in the application itself. Again, these SaaS companies are application companies. They wanted to offer their applications to lots and lots of customers and still control their hardware costs and control and make operating a large, a cloud, if you will, a cloud with lots of customers' data, make it cost effective and make it operationally cost effective and not spend so much money on hardware you can never be profitable. So they did this interesting thing, which was invent kind of a layer on top of the Oracle database to allow multiple customers' data to coexist in a single database. But they did that at the application level because it wasn't available at the database level. And it was before VMs were terribly popular. Remember, these SaaS companies started. NetSuite started in 1998, Salesforce started in 1999. They started a long time ago. And there really wasn't a lot of alternative but to build these applications and make them multi-tenant and do that at the application layer. Now, as you'll see in a moment, there are problems with that. But we recognize this problem. As you know, I've been very critical of the notion of multi-tenancy in applications. Not critical of multi-tenancy, period, in the abstract, but implemented at the application layer, I think it is a big mistake. Albeit, back in the late 90s, I'm not sure they had much of a choice. Traditional databases, the Oracle architecture, other databases, have always had separate databases for separate applications or separate suites of applications. You might have an ERP database, and that database would have its own dedicated memory, its own dedicated processes managed by the operating system, its own dedicated files, separate. And then if you had CRM applications, they would be in a separate database. And that database would have its own memory, its own operating system process, its own separate files. And one dataware, and you know, this slide shows 3 databases, but typical companies have hundreds, sometimes thousands of separate databases, each with their own files, each with their own dedicated memories, often with their own dedicated hardware, these separate databases. And as you get hundreds, thousands of databases, becomes very expensive just to manage, just to keep track of. You have to back up these thousands of databases. You know, that's a lot of work. You have to buy hardware for these thousands of databases, so on. But that's the way it's been. That's the way it's been until, I guess, according to what was on the thing on the screen before I got over, until 2013 when we're going to deliver 12c. But with Oracle 12c, we have a fundamentally new architecture. And we introduced the notion of a container database. And that container will then hold some number of separate pluggable databases. But it's a single database. You got one database. You have one dedicated set of memory, one set of operating system processes, and then you can plug multiple separate private databases into that single container. So the database management system is responsible for keeping those databases separate and private and secure, not an application, but the underlying database technology is responsible for the multi-tenancy. So you get, as a result of this, remember why people built multi-tenancy into applications in the first place. They built it into applications because they were trying to save on the operational costs, backing up hundreds, thousands of customers' data separately. They were trying to save hardware costs, so they wanted this consolidation of multiple customers into a single database. But they did it at an application layer. We're doing it at the database layer. So we get all the benefits of multi-tenancy. That's hardware efficiency, manage many as one, back up thousands of customers, or thousands of databases, a single backup, you can recover any one of them by themselves. We get all of those hardware efficiencies, operational efficiencies, without any change to the application at all. You don't have to touch the application. It's very different than what the early SaaS vendors did. These pluggable databases are vastly more efficient than traditional databases. This is comparing Oracle to Oracle. Same hardware, Oracle version 11, Oracle version 12. We use much less hardware. You can see the slide where we kind of max out the hardware with the traditional database. We use 1/6 as much hardware and run 5 times as many databases. We got huge efficiency gains going away from a single database, to the notion of a multi-tenant database. 6 times less hardware, 5 times more scalable. That's hugely important to conventional users of databases or SaaS companies. Again, you back it up, you back up hundreds of databases and restore any one at any point in time. This is the notion of manage many as one. So you get operational efficiencies as well as hardware and scalability efficiencies. But most important, with multi-tenancy implemented at the database level, you get security to go along with your efficiency. That each customer's data is safe in a separate, private database. All of the database security features work. Auditing works. Redaction works. This may come as a surprise. These things do not work properly in a multi-tenant database. If you build a multi-tenant database, you have to build your own security on top of that. The conventional database security, some, not all, encryption still works, but auditing doesn't work properly. Redaction doesn't work properly. A lot of the security features don't work properly in a multi-tenant database. They do with, they don't work properly if multi-tenancy is implemented at the application level. They do work properly in Oracle 12c. By the way, the same thing is true of tools. A lot of your database tools don't work if you've implemented multi-tenancy at the application layer. Query tools don't work properly. Reporting tools don't work properly. BI tools don't work properly. The application companies, the SaaS application companies who built their own multi-tenancy have to build their own query and reporting tools because the standard query and reporting tools will not work properly. Now, they can adopt Oracle 12c and all the security stuff will work properly and all the query and reporting stuff will work properly. Oracle 12c is the foundation for an expanding business, cloud business at Oracle Corporation. It is the foundation, the software foundation of the Oracle Cloud. Multi-tenancy built at the right level. The hardware foundation, this is my fourth and last major announcement of this presentation. The hardware foundation of the Oracle Cloud is Exadata version 3, X3. Database in memory machine. If you thought the old Exadatas were fast, you ain't seen nothing yet. Exadata X3 is designed to store your database. No, all your databases. All your databases in memory. Everything is in memory. A single rack, a single Exadata X3 rack has 26 terabytes of memory. 4 terabytes of DRAM, 22 terabytes of flash memory. You can store, then we compress it, we compress the data by a factor of 10. So in terms of user data, we store in a single rack 220 terabytes of your data in a single X3 rack. That's an astonishing number in memory. You virtually never use your disk drives. Everything is in semiconductor memory. When we when we build the Oracle Cloud, we are building and extending the Oracle Cloud using the X3 database machine, database in memory machine. If you buy an Oracle private cloud from us, what we install is Exadata and Exalogic behind your firewall. Exadata X3 behind your firewall. Disk drives are becoming passé. They're good for storing images and a lot of data we don't access very often, but all of your active data is migrating off of old mechanical rotating disk drives to semiconductor memory. And the first big move in that direction is the Exadata X3. Flash memory, we're increasing flash memory by a factor of 4 versus the previous generation, versus the Exadata X2, and we're keeping price the same. Okay, so 2 M's, multi-tenancy and money. Draw an applause, I'm beginning to figure this out. We have greatly enhanced our flash cache in Exadata. So Exadata used to use the cache memory for reading, to speed up reads, a million read IOs per second. Now we've enhanced the new generation of Exadata software, flash cache software, now sends not only all reads to flash, it sends all writes to flash as well. That makes writes, our database writes are now 20 times faster. Now, I've stood up here and said before that Exadata was 50 times faster than conventional machines, and kind of guaranteed a factor of 10. But now we've just made it so much faster. We hardly ever go to disk. Everything's in flash, and we do writes 20 times faster. We use less power. Everything's faster with the Exadata X3, and we consume less power. We've been in this business a long time. We started with a partnership with Hewlett-Packard back in 2008, where we built our first Exadata machine, which interestingly enough had disk drives and DRAM, but no flash. After we bought Sun Computer, we started making our own Exadatas, and we started putting flash memory into them. A little in the beginning, and more over time. We went from being a data warehouse machine to handling online transaction processing, today handling multiple massive databases, all in memory. Huge databases in memory. I know I know that SAP has an in-memory machine that, is a little bit smaller than what we offer. We offer 26 terabytes of memory. They offer 0.5 terabytes of memory. So, I think it's called Hannah. Her name is Hannah. So I promised Mark when I was going to do this presentation, I was not going to mention them. I'm glad to keep the promise. Okay, so I don't intention to mention that Hannah in-memory machine is like really small. Okay, so 26 terabytes of memory. Not a database in memory, but all your databases in memory. And this is a real tongue twister. The X3 has when I talk about flash, a lot of people think, oh yeah, flash, solid state disk drives, SSDs. No. This is not like solid state disk. You can use flash in a lot of different ways. This is flash as part of a memory hierarchy where DRAM is at the top of the hierarchy. 4 terabytes of DRAM, 22 terabytes of flash cache, not semiconductor disk. And then lots and lots and lots of disk storage below that. Flash cache will automatically keep all of your active data in memory. Flash disk does not. Flash disk does not adapt with every read and write I/O. Flash cache does. All of your it really is a memory hierarchy. It's a smart memory hierarchy. It's a heuristic memory hierarchy. And I'm sure all of you will be walking around this week talking about X3, H2, M2, which is not a robot, but it's the Exadata X3 heuristic hierarchical mass memory system. It kind of rolls off the tongue, and I know a lot of you are going to have little badges that have that on it. Okay. Again, if you look at the speed of this thing, it really is astonishing. You would need thousands or tens of thousands of disk drives to deliver the I/O capacity of a single Exadata rack. Same thing, and now the Exadata, as I said before, I'm repeating myself a bit here. The Exadata smart flash cache now sends not all of its reads to cache, but all of its writes to cache. We now can do a million writes per second on a single Exadata rack, 1.5 million writes per second in a single rack of Exadata. You would need 10,000 disk drives for that kind of write capacity. 10,000 disk drives. That would be 100 racks. 100 racks compared to a single Exadata rack. You want to, kind of from that wall to that wall versus a single rack. It really is astonishing. This will make all existing Exadata customers happy. The write cache is really a software feature. I mean, again, we said, version 2 of Exadata and X2 of Exadata both had cache. So if you have a V2 Exadata or an X2 version of Exadata, you have a lot of cache memory in that system. When you push the button and upgrade your Exadata software, you will suddenly get your write IOs sped up by someplace between a factor of 10 and a factor of 20. So you just press that button and you get the software upgrade, and the write back flash cache works on the older versions of Exadata as well. Okay. So we said we'd need 100 racks of disk drives to do the same amount of I/O as a single rack of Exadata. That is really not a fair comparison, because the modern suppliers of disk arrays put flash in their disk arrays. They have solid-state devices, solid-state disks. They have DRAM caches built into their arrays. And EMC just announced the latest and the very greatest of all of the disk arrays. And they made a point of showing how they just smoke the competition. That the great new VMAX 40K is way faster than anything the competition can come up with. Well, that is the competition that makes disk arrays. So you might ask, okay, how does that compare? How does it say, by far, number one in high bandwidth apps? Number one, that's what the ad says, number one in high bandwidth apps. So how would that compare to a single rack of Exadata? I'm sure you're all wondering. So who do you think how many people think EMC wins? You don't think I put the slide in, do you? You think I wouldn't have brought this thing up at all, right? Okay. There it is. So in bandwidth comparison, and that's what, can you back up to slide one, please? And that's their point. Number one in high bandwidth. This is a bandwidth comparison. They're comparing the ability to move data off of storage and into servers. And they say they're 3 times better than anybody else, any of the other array manufacturers. They're way better than anybody. Brand new system. Okay. This is how we compare, and that is the actual size of, you'd have to have the largest VMAX 40K made to get within half a single Exadata rack. And of course, they're done. They can't scale up. That's it. 52 gigabytes per second is maxed out. We just can go, and like the Energizer Bunny, it would just get faster and faster and faster. So there really is no comparison. Thank you. And a lot of people think of Exadata as saying, God, that thing is fast. Now it's even faster. Those guys are crazy. The last one was faster than I needed anyway. Why are you making it faster still? It's like they just delivered a car to me that goes like 9,000 miles an hour. The last one that went 5,000 miles an hour, I can't drive on 101 anyway. Why are they doing this? Well, you don't have to take all of that performance as performance. You know, it costs way less to buy a single Exadata than to buy an EMC VMAX 40K. It's cheaper. The reason we're making these things faster is to improve not just their peak performance, but improve their cost performance. One rack of Exadata is way cheaper than a maxed out 40K, and you get all the data, you get all the database stuff as well. So you can save money, a lot of money, by using these engineered systems, Exadata and Exalogic. The reason we keep making them faster is that there are some applications that really require that huge capacity, like you're building a big cloud, and you want to have a lot of performance in the cloud. In some cases, you can buy a much smaller machine and consolidate your maybe buy one Exadata and consolidate 100 separate databases or 1,000 separate databases onto a single Exadata. You will save so much money in storage because of our compression. It'll more than pay for those Exadatas time over and over and over again. Well, I had to include this slide as well. We're not only much faster than EMC storage, we're much faster than IBM servers and much less expensive. This is an identical configuration. This said, okay, let's take a half rack of Exadata X3-2 and configure an IBM servers and storage identically. Same number of CPUs, same amount of memory, same amount of disks, same amount of flash. Everything's the same. By the way, the Exadata runs a lot faster than the P780. Forget that. Forget the fact it runs a lot faster. It stores a lot more data because of compression. Forget that. Forget about all of that. There's an 8-to-1 price difference with these engineered systems. For some people, that's a big deal. And now we have an Exadata, a new member of the Exadata family, the Exadata X3-2 8th rack. This our smallest configuration with an entry, with a list price of $200,000. And I bet if you talk to an Oracle salesman, you can get a better price than that. I know these guys and gals, and they're always ready to deal. So the street price is lower than the list price, but that's very, very attractive. And this thing is extremely fast. It has all of the Exadata features, lots of flash, runs extremely fast, can replace a pretty big IBM server with this Exadata machine. Okay. Oracle Cloud announcements today. We announced that we're not going to participate just delivering SaaS applications and an underlying platform set of services, including database, Java, middleware. We're also going into the infrastructure business because we think our SaaS customers and our PaaS customers are going to require us, or have asked us, and require us to be in that business as well, so they could move any application they want to the cloud, either the Oracle public cloud or a private cloud behind their firewall. And we're offering that private cloud option. We think that's extremely important, depending on the industry you're in, that you might be legally required or just have a preference to store that data behind your firewall, but still take advantage of the benefit that we pay for the servers, we pay for the software, we manage it, we continuously upgrade it, and we charge you a simple monthly fee. That the idea of multi-tenancy is very attractive also, because you can, it allowed the early SaaS suppliers to deliver their applications at a pretty reasonable price, because they did a good job of using hardware resources efficiently in their SaaS clouds. But there are problems with that. And we're all going to be better off now that multi-tenancy is being moved from the application layer to the database layer, where people are going to get the same efficiencies of multi-tenancy, but this time they're going to get it implemented in the database with full database security and all the database tools working as advertised. And finally, as we move more and more of our databases onto Exadata machines, those databases aren't going to go onto disk drives. They're going to go into flash memory, where the information is available instantaneously, where you can ask a question and get an answer at the speed of thought, where the new generation of clouds are going to deliver answers faster than you ever imagined was possible because of the X3 database in-memory machine, the world's fastest computer for business. And they start at a price that's less than $200,000. Thank you very much.